Hello, and welcome to Key Stage 4 chemistry topic, fractional distillation. Before we get started, can you please make sure you have a pen, a pencil, a ruler, and a highlighter or another coloured pen or pencil for self-assessment. Before we get started, can you also make sure you also are in a quiet room, no distractions, and no technology to distract you from this learning session. Can you pause the video just for 10 seconds and write down a learning objective to understand what happens during fractional distillation? So pause the video now. Okay, so for the retrieval practice, there's only 3 questions. Can you pause the video just for 3 minutes and have a go at the first 3 questions here? So pause the video, 3 minutes, go. Okay, hopefully you've answered those 3 questions now. Can you pick up another coloured pen or pencil and we'll go through this now. First question asking what is a hydrocarbon? So a hydrocarbon is a long chain polymer of only hydrogen and carbon atoms. So only hydrogen and carbon atoms there. Hydrocarbon, hydrogen and carbon atoms together. Question 2, why are alkanes saturated? Well, saturated means that only all the hydrogen carbon atoms in the alkanes are all joined by a single bond. They're all joined by a single bond, and that means they are saturated. There's no more bonds that can be made, and they're all joined by single bonds. And a simple drawing of hexane, which is a type of alkane, so it's a type of hydrocarbon in skeletal formula or a displayed formula. That's another way of saying that. Just on here. Okay, so it's got hexane, that means 6, so 1, 2, 3, 4, 5, 6 carbons. Okay, so you can give yourself a mark out of 3 for that. And excellent, if you've got 3, 2, well done, 1, let's address those misconceptions there. Okay, so what is this learning session about? We're going to describe the process of fractional distillation and then explain the importance of boiling points in relation to the process of fractional distillation. So, for a little starter, using the laptop or computer or mobile phone available to you, can you find out the AQA meaning of the following words? Viscosity, flammable, and boiling point. So find the definitions for them. Give yourselves 5 minutes for that, and then we'll go through it and make sure we understand it. So 5 minutes, go. Okay. Can you pick up a green pen or another coloured pencil and tick these out of 3 as coming up? So viscosity, that is a measure of how difficult it is for a substance to flow. The higher the viscosity, the thicker it is. So water has a very low viscosity because it flows very easily. However, custard has a very high viscosity because it's very thick, but it still flows. Flammable, able to ignite or burn. That's very simple, that. So able to ignite or burn or set on fire. And boiling point, the temperature at which a substance rapidly changes from a liquid to a gas. Emphasis here on a liquid to a gas. That's the temperature it changes from a liquid to a gas. So give yourself another mark out of 3 for that, guys. Excellent if you've got all 3. 2, well done. 1, let's just add any corrections there. Okay, so the first thing we need to talk about is crude oil. You might have heard about oil before. Well, oil we get from underground is called crude oil. And it's obviously a finite resource. That means there's only a limited amount available, found in the Earth's crust, so deep underground. And it is the remains of the organisms that lived and died millions of years ago, mainly plankton, but also animals and plants. Over time, the pressure has squeezed them down into oil over millions of years. That's what crude oil is. Looking at a molecular level, crude oil is simply just a mixture of hydrocarbons. So those long chain polymers or rings, they can either be in chains or in rings shown here. So we've got the carbon atoms indicated in black and the hydrogen atoms surrounding it indicated in white. And how are these used? How is crude oil used? So we separate it out and it's used for fuels, such as petrol and diesel for cars, vans and buses and so forth, kerosene for airplanes, heavy fuel oil, and liquefied petroleum gases. Also, it's used for feedstock for petrochemical industry and for plastics. So all the plastic bags, all the plastics that surround the food and encase food are made from crude oil. And this is the process we're going to find out next. Before we get started on the first task, can you pause the video just for 5 minutes and copy down and draw in this information here? And I'm going to explain it in a few minutes. So pause the video for 5 minutes, draw this in, and get the labels down, and then we'll move on. Okay, you should have got that drawn in, guys. We're going to label and explain what each part of this means. So as I'm going through the next few slides, going to be jotting down information around it all underneath. So the majority of fractions used for fuels are only a small amount of chemical synthesis and making polymers. So you've got a mixture of crude oil, which is going to be, obviously, as we mentioned, it's crude oil molecules of different sizes, so lots of different sizes here, or lots of different hydrocarbons. The crude oil molecules enter as a gas. It enters as a gas, they're already heated. The oil is as a gas. It then is separated out, so the large molecules condense straight away and turn into a liquid. They're cooled down into a liquid at 340 degrees, so the larger molecules. But then the smaller molecules move further up, so the smaller hydrocarbons move further up the column and are separated out at a lower temperature. Because they are smaller molecules, they don't take as much temperature energy to break them down into liquids. And then at the top, the smaller molecules, they reach the top, and each fraction condenses at its boiling point. That's the key part I want you to understand, guys. Each fraction condenses at its boiling point, so each different sized hydrocarbon in the heated crude oil is separated out according to its boiling point. So you have the largest molecules at the bottom, the middling ones in the middle, of course, and then the smallest molecules, the smallest hydrocarbons at the top. So this mixture of heated crude oil is separated out into each individual hydrocarbons, which is then used for lots of different fuels. So that's shown just there. Each fraction condenses at its boiling point. So what I want to do, guys, is having done that information, I want you to pause the video after getting that down, having that information, look through the information we got down today, and create a flowchart to describe the process of fractional distillation. So step 1, 2, 3, there can be up to 5 steps, guys, but you can put into 3 steps. Fantastic work. So pause the video. I'll give you 4 minutes for that and have a go. So 4 minutes, go. Okay, time is up there, guys. Your 4 minutes is up there. Can you pick up a green pen or another coloured pen and pencil, and we'll go for this and add in anything you don't have. So a flowchart should be just something like this. So in bullet points or numbers, I've got 5, but if you put it down into 3, fantastic. So the first part you need, guys, is to heat the crude oil into a vapor. The crude oil must be as a gas or a vapor here. It must be in a gaseous vapor state. The column is hot at the bottom and cool at the top. That's the second part. That's how we're going to separate out. So at the top it's coolest at 40 degrees Celsius, and at the bottom it was 340 degrees Celsius. Hydrocarbons evaporate and separate based on the boiling point. Obviously the smallest hydrocarbons go to the very top, where it's the lowest temperature, and the longest ones go to the very bottom and condense there. They cool and condense at respective boiling point temperatures, turning into a liquid state, and the low boiling points at the top, high boiling points at the bottom. Those are the 5 key points, guys. Can you give yourself a mark out of 5 for that? Even if you put 3 bullet points, if you mentioned the 5 points, you still get 5 out of 5 there. If you got 5, excellent, guys. 4, very well done. 3, good. 2 and below, let's add in the corrections there. Okay, so just looking at this information here, guys, I do not want you to write this down. What pattern can you see from the information table? I'll give you 30 seconds to have a look through this. What pattern do you notice? Okay, so hopefully you had a good look at that, guys, that information there. A key GCSE skill for science is using data and analyzing it and interpreting what that data means. So we've got different temperatures here and different average number of carbon atoms in chains here. So the key part hopefully you understand, guys, is that as the temperature goes up or increases, so does the average number of carbon atoms in the chains. This is because the more energy is required in heat to break down the longer chains. The more bonds there are in these hydrocarbons, these covalent bonds are very strong. The more of them there are, the more energy, the more heat is required to break them down. Okay, guys. So we have a GCSE question here. Can you pause the video, once again looking at the information, and then describe the relationship between the number of carbon atoms, just done there, in an alkane molecule and the boiling point of the alkane molecule. It's only 1 mark, guys, so that's 2 points, 1 mark. Go. Okay, guys, so that's a GCSE question there. Hopefully you had a good go at that. Can you pick up a green pen or another coloured pen or pencil? And we'll go through it now. So you've got a couple of tables here just showing you the relationship between each alkane and alkene, and also the number of carbon and hydrogen atoms there are and the boiling points for each one. So hopefully you notice, guys, that the more carbon atoms there are, the higher the boiling point. So the more carbon atoms, so C2 here compared to C6, minus 88 degrees Celsius compared to plus 69. And then the same here, C2 here for ethene is minus 104 degrees Celsius, and hexene, C6, plus 64. There's an increase in the trend, there's an increasing trend. So the more carbon atoms there are, the higher the boiling point. Okay, guys, so that summarizes the topic of fractional distillation in chemistry. Have a wonderful day, guys. Thank you for participating and take care. Thank you. Bye.